Hello everyone, and welcome to my lesson on simple exponential equations. This corresponds to section L of chapter 6 of your textbook. Your textbook, however, calls it exponential equations. I added the word simple because you are not expected to know logarithms. So if you're getting help from somebody, or if you have a tutor and they start talking about logarithms as a technique for solving these, interrupt them and say, no, you don't have to use logarithms. An exponential equation is one where the variable or the unknown value is in the exponent's position of the equation. For example, 3 to the power of x equals 9 is an example of an exponential equation. The unknown value, the x, is in the exponent's position. X squared equals 4 is not an exponential equation because the unknown value is not the exponent. It does have an exponent, but the exponent is not unknown. The exponent is known, so that is not an exponential equation. Now, the property that we're going to use in order to solve simple exponential equations is in your books on page 198, and it states, if the bases are the same, then you can equate the exponent. So, for example, if you have some base a to the power of x is equal to the same base a to the power of k, then x is equal to k. So in other words, what essentially happened here is the bases got canceled and all you're left with then is the exponents. So we're going to go through 4 examples, and starting with this one, we have 2 to the x equals 16, and what we want to do is write this equation so that the bases on either side of the equal sign are the same. So I start with 2 to the x. Well, that base is as simple as it's going to get. 2 is a prime, well, 2 is a prime number. And then 16, I'm going to actually rewrite that as 2 to the power of 4. Now my bases are the same, and I can set the exponents equal to each other. So I have x equals 4. Okay? And I'm done with that problem. Now, you may be thinking, well, it didn't occur to you to rewrite 16 as 2 to the power of 4. Let me show you an alternate technique here. You could have said, let's start with 2 to the power of x equals 16, and we could have said, all right, 2 to the power of x is equal to, whoops, let's undo that. 2 to the power of x is equal to 4 squared. That's most students' initial thought when they see 16. And then you go, well, this is true, 16 is 4 squared, but this does not help you because now your bases are still not the same. So then what you can do is now rewrite 4 to be 2 squared is equal to 2 to the x. Okay? This said 4 squared, and now I change 4 to 2 squared. So 4 squared becomes 2 squared squared. And we know from our properties of logarithms that when you have a power raised to a power, you're going to multiply those powers. So that's going to now be 2 to the power of 4 equals 2 to the power of x. And so you do end up with x equals 4, the same as I did up here. But I had to add an extra step there. Okay? Next example, I have 2 to the power of x plus 1 equals 1 over 8. Again, you want them to have the same base. And what I know about 8 is it is equal to 2 cubed. Your knowledge of exponents here is going to be very important. To know that what 2 cubed is equal to, and 3 cubed, and all that kind of stuff. Now, this is useful. Now the base is the same, but this is in the denominator of the fraction. So I'm going to put this up to the numerator of the fraction, and when I do that, you also may remember from your laws of exponents that that exponent is going to become negative. So that's 2 to the negative 3 equals 2 to the x plus 1. Okay, now my bases are the same, so I can essentially cancel those bases and set the exponents equal to each other. So I have x plus 1 equals negative 3. And then I just need to subtract 1 from both sides, and I have x equals negative 4. And that's my final answer. Number 3, 25 to the x plus 1 equals 5. Well, 25, as you all know, is 5 squared. So it's 5 squared to the x plus 1 equals 5. And I'm going to go ahead and add an exponent on there as 5 to the first power. Now again, we have a power raised to a power, And the key here is you're going to have to remember to distribute that 2. So in the next step, we're going to have 5 to the power of 2x plus 2 equals 5 to the power of 1. Now the bases are the same, they can cancel, and I set my exponents equal to each other to get 2x plus 2 equals 1. And then I proceed to solve for x. So I'll subtract 2 from both sides, and that's going to be negative 1. And I will divide both sides by 2, and I'm going to get negative 1 half. And let me show you that step there. Just kind of skipped the whole subtract 2, subtract 2. So here you can see 1 minus 2 is negative 1. Okay? Let's put a highlighter around that, box around that. Okay. Next example, 4 to the x equals 1 over 2. So we have a fraction much like we did in the previous example, in example 2. So I'm going to rewrite 4 to be 2 squared to the power of x. And I'm going to change that to be 2 to the negative 1 power, because remember this is really 1 over 2 to the positive 1 power. So when I put that up in the numerator, the exponent becomes negative. Again, power to a power, so it's really 2 to the 2x equals 2 to the negative 1. So 2x equals negative 1. And so I divide by 2, and x equals negative 1. That's ugly. Excuse me. X equals negative 1 half. Let's put a little box around that. Okay. Hey, look at that. Both of these answers were negative 1 half. Okay, and the last example, 4 to the x equals 8. So here we're going to rewrite 4 to a base of 2 with a base of 2, so it's 2 squared to the power of x, and then 8 is 2 cubed, which is quite convenient because now the bases are both 2, so that's 2 to the power of 2x equals 2 to the power of 3, so 2x equals 3, and then you'll divide by 2, x equals 3 halves. And that's the answer. Okay, so the key here is that you want to always rewrite your equations so that the bases are the same, and then you can equate their exponents. Now, particularly when you have a 4 and an 8, I know that your tendency would be to think, well, 4 is twice 8, but don't be thinking about multiplication, always be thinking about exponents.